Welcome back. This is going to be the second part of the 11-2 video. And if you remember, we were preparing to run a two-sample t-test, a paired t-test. Okay, a paired t-test. And the reason we were going to use a paired t-test for this data set, and you can get the data set from the last video. Okay, it was up there for most of the video. The reason we're going to do that is because the data was paired. Okay, each critic had two different ratings, and those two ratings formed a natural pair. Okay, so let's start with this. Okay, what we have to do, you had two lists, a list of ratings for Superman and a list of ratings for the Avengers. And what we have to do is for each one of the critics, we have to find the difference in the two ratings. Okay, so for each of the 10 critics, you take the rating for Superman minus the rating for the Avengers to get a difference. Okay, now the easiest way to do that on your calculator, and listen carefully here, type the ratings for Superman into L1. Type the ratings for the Avengers into L2. Then go to L3. Up arrow to where L3 is highlighted, and then type in L sub 1 minus L sub 2, and then hit the down arrow, and it should populate L sub 3 with the differences between L sub 1 and L sub 2. Okay, I'm not going to write the population of differences up here, but I do have the summary statistics for those differences. Okay, so let's begin here by defining the parameter of interest. Mu sub d. Okay, the mean of the 10 differences. Each critic has a difference associated with him or her. And the null hypothesis, before we get to the null hypothesis, let's finish defining the parameter of interest. This is going to be the true mean difference. Now, I have to specify something here. The way we calculate the difference here, and it doesn't matter which way you do it, but to calculate the differences, we took the Superman rating minus the Avenger rating.
Avengers is better.
In parentheses, I'm going to write Superman minus
Subscribe
Avengers.
to Teddy Paprick, because he likes the Avengers.
Teddy. In ratings among all critics. Okay. All right. Now, there's just one parameter of interest here. Okay, even though we had two lists, remember what we do is we use those two lists to create one list, a list of differences. And then our null hypothesis is going to be that the true mean difference in ratings is 0. In other words, our null hypothesis is that that Superman and the Avengers, the mean difference in the ratings between those two movies is going to be 0. And then our alternative hypothesis for this case is going to be that the true mean of the differences, I wrote the wrong symbol there, it should be greater than 0. So I defined the parameter of interest. I wrote the set of hypothesis statements. All right, next, I'm going to erase this now. And we will name the procedure. It's right up here. I'm not going to rewrite it. It's called the paired t-test. Then I'm going to write the sample statistics, okay? So I've got my list of 10 differences. I type them into my calculator. I run the one variable stats. And here's what I got. I got x bar sub d is 0.453. the standard deviation of the differences is 0.488. Okay. Sample size is 10, which means our degrees of freedom are 9. Let's go ahead and choose an alpha level. I'm going to choose alpha is 0.05. How about? Okay. And now we come to the part where we have to check the assumptions or check the conditions. Okay, now, the first condition is this has to be a random sample from the population of all critics in the United States. Okay. And then as far as normality of the sampling distribution goes, okay, this time we are running the test on the population of differences. So we have to be able to assume somehow the sampling distribution of differences is approximately normal. Well, we do that the same way we did it with the one sample t-test back in chapter 10, because essentially what we're going to be running here, as you'll see, is a one sample t-test. Okay. Spoiler alert: the one sample t-test, the paired t-test is run exactly the same way on the calculator as t-test. Okay, you don't look for something that says paired t-test because you won't find it. It's simply just t-test. All right, so if the number of differences were greater than 30, we would be fine. We could justify normality of the sampling distribution based on that. It's not, so we would have to make a box plot of the differences. Okay, now I'm going to write box plot of the differences, and I'm going to rely on the viewers at home to actually create that box plot, because I'm not going to do it. But what you do is you take your list of differences and you create a box plot of the differences. And then you know what to say from there. You say, since the box plot is reasonably symmetric and contains no outliers, we can assume normality of the sampling distribution. Okay, I don't think I have to repeat that. You've heard it over and over again. Okay, so those are our two conditions. All right, and notice I did say random sample singular. That was a random sample of critics. Yeah, they each gave us 2 ratings, but it was just a single random sample. Okay, so we've checked our conditions. We've got our sample summary statistics. Like I said, this is run just like the one sample t-test. So the test statistic that we'll use is just the same t-test statistic that we used for the t-test in chapter 10. X bar sub b minus mu sub b. Okay. The sample mean of the differences minus the hypothesized mean of the differences divided by the standard deviation. Oops, too big of a square root there. S sub b over square root of n. Okay, so that's the same test statistic that we used before. Observed minus hypothesized divided by the standard deviation of the test statistic. Okay, when I calculate that, remember you're just going to run the one sample t-test on the sample of differences, and here is what I got. T equals 3.06. P equals no. Well, apparently I wrote it down incorrectly. And my phone, which is where I was doing that, is currently being used to film this video. So let me just, I'll tell you what, you know what, I think I actually remember what it was, now that I think about it. And you can double check me, of course, but I think that it is 0.006. Okay, remember, just run on your calculator, see what you think. Okay, you have the statistics. Okay, so now, what is the conclusion based on this p-value? Well, P is definitely less than alpha this time. Okay, so we'll write the conclusion since P is less than alpha, we reject H naught at the 0.05 level. Okay, we all know that if we reject H naught, then the next words out of our pencil have to be there is sufficient evidence to conclude that the true mean of the differences is greater than 0. Okay, so essentially remember I ran it in the last video as a 2-sample t-test where the assumption was independently chosen random samples. Running it that way, which is incorrect, did not result in a statistically significant result. Okay, we did not reject H naught. We did not find evidence that there was a difference in the ratings. But running the correct test, we did. Okay, so we my son Teddy, he likes the Avengers better than Superman, but he's very young, and I don't know if he's ever actually watched Superman.
Hey, Avengers are better.
I'll stop with the opinions about Marvel movies.
Iron Man for life.
But yeah, it should come as no surprise to adults, I suppose, that Superman would be higher rated than the Avengers. Okay, so that is the paired t-test. There is a confidence interval. That's going to have to wait for another video. You could probably figure out how to run it all by yourself.
You're at 12 minutes.
Okay. What you do, of course, you could run it on this same data set, and just instead of running a hypothesis test, you run a 1-sample t interval, or just t interval on your calculator, okay, to get an interval of plausible values for the true mean of the differences. Okay. That is all. Listen, I may or may not post some videos over the weekend. I think you probably have with 11.1 and 11.2 enough to keep you occupied. Quick preview of what's to come. We are going to finish chapter 11. I think there's just one more section, to be honest. And we have a couple sections in chapter 12, which will be lots of fun. We'll do one section out of chapter 13, and then, of course, some of you need to get the personal finance credit, so I'm going to be posting some videos on personal finance. Now listen, if you have questions, you can email me, you can send a video to me, and if I get enough questions, maybe I'll make a video where I attempt to answer some of them. Stay safe, don't interact with anybody other than your family, and we hope to see you soon. Goodbye.
And I'm the last one speaking. Avengers are better.